So let's begin. Let's start with the theory. Quadratic equations can be written down in the following form: ax squared plus bx plus c. Something very important when writing is, of course, to remember that a cannot equal 0. Why a cannot equal 0? Because if we substitute a equals 0 into here, then all of this just disappears, and we get a linear graph, making it just by definition not a quadratic. So there are three main ways to solve quadratic equations. The first, and it is called the quadratic formula. And I hope all of us know what the quadratic formula states. That x, of course, all of these little letters correspond to these letters. Nice. To these coefficients. Okay, that's the first method. Second method is a bit more challenging. It's called factorizing. And finally, completing the square. And completing the square is one that many students struggle with because it requires a bit of thinking, funnily enough. So first of all, the quadratic formula. Let's say we've got a quadratic equation. Some of you might have already seen that you can just divide everything by 2. And so you get, now, over here, you can apply the quadratic formula, of course. The quadratic formula works for every single quadratic possible. That's the entire idea. Basically, these three just offer different ways of solving. So really, you should focus on trying to solve it through these two. But if these two don't work whatsoever, then yeah, you have to use the quadratic formula. So x squared plus 2x plus 1 equals 0.
Well, before we continue with this section of this video, we would just want to make clear one confusion. That is, if this is the quadratic formula, which is ax squared plus bx plus c, here a is 1. So if you see this equation, it is 1x squared plus 2x plus 1. Well, 1 is not really needed, and that's why we don't write it, because 1 into x is x itself. So 1 into x squared is also x squared itself. But here, to map out with the general equation, you can see that 1 is equivalent to a, b is equivalent to 2, and c is equivalent to 1.
So let's go. Quadratic formula. Negative b, in this case negative 2, plus or minus the square root of b squared, so 4, minus 4ac. Now ac is 1 because, and this is another one of those issues that many students have. Here is a 1, there is no 0. If this would be 0, then there will be none of this, because 0 times x squared is 0. So 4 minus 4ac, so ac is 1, 4ac therefore is 4. 4 minus 4, actually I gave way too much space over here. 4 minus 4 over 2a. A again is 1, so over 2. Now this all just simplifies to negative 2 plus or minus the square root of 0 over 2. I hope all of us know that the square root of 0 is 0 equals negative 2 over 2. Why negative 2? Why there's no plus or minus? Because, well, it doesn't really matter if we add or subtract 0 equal to negative 1. So the answer is, actually I forgot to put an x equals, which is critical. So the answer is x equals negative 1. Nice. So this is the quadratic formula. There really isn't any more to it. It's just substituting different values into the formula. So now let's go on to factorizing. And we'll actually factorize this exact one because it's a nice one to factorize. So factorizing, the entire idea behind factorizing is that you have to bring the quadratic down into the form of x plus a times x plus b equals 0. Now, immediately I'd like to address your attention to, so let's imagine that x plus a times x plus b is in fact equal to 0, which is the result that we want to get. So then we can say that it's either x plus a that is equal to 0 or x plus b that is equal to 0, right? Because say a times b is equal to 0, we can say that either a is 0, either b is 0, or both of them are 0. we get that x is equal to negative a and that x is equal to negative b. Now, this I will just put in a little box because it will come incredibly important as we are going to be solving. But how do we factorize? There is one big way to factorize. You have to look at the c coefficient, right, at the 5 in our case. And we have to see how can we break down this 5 into its factors. So, how do we do that? So, 5 can be broken down into a 5 and a 1. Okay, so then we look at the 6. And the 6 has to be an addition of one of the two factors of 5. So in this case, it's just a simple one because it's 5 and 1, 5 plus 1 is 6. I will explain where this is coming from a bit later. So if you are confused right now, don't worry, I will cover why this is so in a few minutes. So we can just say that x plus 5 times x plus 1 equals 0. Now this is very easy to check. And why this is easy to check? Because you just expand the brackets. So you get x squared plus 5x plus x plus 5, which is, in return, x squared plus 6x plus 5, which is just identical to this.
So just taking a quick break before we continue, let's solve few more examples of factorization. This process is also called the middle term splitting because essentially we need to split this middle term into the factors. Let's solve the first one. So as we can see, the last term is 4. So we need to find the factors of the last term, which is 2 into 2. Now these factors have to be in a way that when we multiply these two numbers, it gives us 4, but when we add or subtract these two numbers, it gives us 4x. Right, so right now it's giving us 4. How can we get 4x? We'll write it as x squared plus 2x plus 2x. So 2 into 2 is giving us 4 and 2x plus 2x is giving us 4x. That is what essentially we need to do. Now we'll take x common here, which leaves us with x plus 2. We'll take 2 common here, which leaves us with x plus 2. Taking x plus 2 and x plus 2 on one side, so we take x plus 2 common, and then we take this x and this plus 2 and we write it this way. So this is essentially x plus 2 is equal to 0 and x plus 2 is equal to 0. So here x is only equal to minus 2. There is no the other answer to it. Let's see the second example. Now this is a special case because x square's coefficient is not 1 here. X square's coefficient is 6. So in these kind of cases, we multiply the 6 with the last term, which is minus 2. So 6 into minus 2 will give us minus 12. Right, this is a special case. Please pay attention. So 6 into minus 2 is essentially going to give us minus 12. Now what we need to divide this into its factors. So it can be minus 4 into 3. Right, minus 4 into 3 will also give minus 12, and when you add minus 4 and 3 you'll get 1, or when you'll add plus 4 and minus 3, you'll get a 1 here. So let's solve it. So it becomes 6x square plus 4x minus 3x and minus 2. Now let's take 2 and x common from here. This leaves us with 2 3s are 6. So 3x plus 4 plus 2, because we have taken 2 common. So this leaves us with 3x plus 2. Right? We took 2x common from this term. Now what do we take common from this term? As we can see, we need to get 3x plus 2. So we can take this minus 1. We can take this minus 1 sign outside, right? And we can keep 3x plus 2 inside, right? Now we are going to take this and this as common. So this becomes 3x plus 2. And we'll take this and this as common, which becomes 2x minus 1. Now this essentially becomes 3x plus 2, which is equal to 0. So 3x is equal to minus 2. So x is equal to minus 2 by 3. This becomes 2x minus 1 is equal to 0. So 2x is equal to 1 and x is equal to 1 by 2. So x is either equal to minus 2 by 3 or 1 by 2.
Now, when in factorizing, we wanted to get it into the form of x plus a squared, oh my god, x plus a times x plus b is equal to 0. In completing the square, we want to do something slightly different. We want to get it into the form of x plus a squared plus b. So, equals 0. So now let's have a look at another quadratic. Now, what do? We do a very simple thing. We have to see how can we get x squared plus 4x in the result of squaring something. So in this case, it is pretty simple, right? We can pretty much see that it's x plus 2 squared. Why can we see that? Because x plus 2 squared, x plus 2 squared gives us x squared plus 4x plus 4. Now, I know what you're thinking, right? We've got x squared plus 4x plus 4. We want x squared plus 4x plus 5. So what do? Right? Well, that is why over here we've got our little plus b. And this plus b is to compensate for the extra a squared that we get when we expand this bracket. So what do I mean, right? This 4 is the result of 2 squared. And we want to get a 5. So how do we turn a 4 into a 5? Obviously, we add 1. So x squared plus 4x plus 5 can be written down as x plus 2 squared plus 1 is equal to 0.
Okay, before we continue, a small break. We just understood the method of completing the square. There's another method called the comparison method that we'll understand right now, which is essentially the reverse of completing the square. So let's just see this method. Now, to continue with this method, we want everything to be simplified first of all. So we want to express this equation into this format. However, this equation is already opened. This equation has a bracket, right? So this is pretty complex. We need to make sure that everything is in the standard format. So let's open the bracket. This becomes x square plus 2xh plus h square plus k. How did I do this? I applied a plus b whole square, which is a square plus 2ab plus b square. So for this, I applied a square plus a plus b whole square, and this is what we get. Now essentially what we need to do is we need to compare all of these equations. We need to compare all of these terms in both of the equations. So let's compare x square and x square. When we compare x square and x square, we don't get anything. Let's move on to the middle term. Let's compare 2xh with 4x. So when we compare 4x with 2xh, x and x cancels. 2 1s are 2, 2 2s are 4. So h is 2. We get the value of h to be 2. Right, now let's compare h square plus k with 5. So h square plus k is equal to 5. We know that h is 2. So 2 square plus k is equal to 5. So 4 plus k is equal to 5. So we know that k is equal to 5 minus 4, and hence k is equal to 1. Now since we have got the values for h, we have got the values for k, the last step that we want to do is we just want to put everything here. So this becomes x plus h value is 2. So x plus 2 whole square plus 1, because k's value is 1. So there you go. This equation is expressed in this format, which is the reverse of completing the square, another method called the comparison method.
So what we do is we just get rid of the 2. Because we're very lazy. Mathematicians are very, very lazy. So we get rid of the 2. Put the 2 under brackets, and we just factorize this part of the equation. I will explain why not the 5 later, because actually it's just not to waste our time. Because again, mathematicians are very lazy. We try to find the shortest path everywhere. So x squared plus 9x plus 5. Now, some of you might start noticing that x squared plus 5x, plus 9x, sorry, looks just like x plus 3 squared. No, it doesn't. Let's change that to 12. Sorry. And let's change that to 6, because 12 divided by 2 is 6. There. And now you might start noticing that x squared plus 6x looks like x plus 3 squared. So 2x plus 3 squared. And now what we want to do over here is we want to get it to only be x squared plus 6x. So after x plus 3 squared, we get x squared plus 6x plus 9. So this 9 we do not want. So we go minus 9 plus 5 equals 0. There. What do we do after that? Well, we expand the bracket. And we go 2x plus 3 squared minus 18 plus 5 is equal to 0. And 2x plus 3 squared minus 13 is equal to 0. Solved. I mean, not solved, of course. To solve it, what you need to do is first you need to get rid of the 2. So let's do that. And actually, let's do that through this way. So first we will carry the 13 over here. Then we will divide everything by 2. And then we'll square root everything because of this square. So we'll go 2x plus 3 squared is equal to 13. Then we get that x plus 3 squared is equal to 6.5. Therefore, x plus 3 is equal to the square root of 6.5. And therefore, I use arrows and the official, therefore, sorry. The square root of 6.5 minus 3 is equal to x. And very important to notice, this should be plus minus because there should be 2 solutions, as it is a quadratic. Plus minus, plus minus. Yeah, this is the solution. And it is actually, now that I think of it, it's actually very important to address this common misinterpretation about square roots. So square root of 4 is not necessarily 2 and negative 2. Many people think this, but this is wrong. Why is this wrong, right? Because square roots, if you look at the graph of a square root, if you just go into Desmos and you look at the graph, the square root does not actually go into negatives. So the square root by itself does not give you 2 answers. The square root gives you essentially a modulus answer. Only gives you a positive one. Now, it's different, right? It's different if you're square rooting, say, x squared, right? Because when you're square rooting x squared, what happens is the x can be positive or the x can be negative, but the squared will just make it positive. So what happens is, if you just say, well, x squared, the square root of x squared is just x, right? You've got it absolutely wrong, because the square root of x squared can also be negative x. So say we substitute negative x into x right now. Negative x squared is x squared. The square root of x squared, according to this logic, is x. So therefore, negative x is equal to x, which is just illogical. So that reasoning is wrong. And that is why in math, we invented this thing called a modulo. It's denoted as 2 straight lines and the expression in the middle. And the idea behind the modulo is that it turns anything into a positive. So say modulo negative 1 will always be 1. It just turns it into a positive. So that helps us to determine whether x is positive or negative. But yeah, in the case with quadratics, it's always plus minus, unless it's just the square root of zero, where there's really no point in doing plus minus because it's zero. Okay, that's all of the ways how to solve a quadratic covered. Thank you for listening. This was Mikhail Shalashov from CambiHub. Thank you.